What is the clique number of a graph? Well, let's read the definition and then we'll see a few examples. A clique in a graph G is a complete subgraph of G. The order of a largest clique in G is its clique number, and we denote that omega of G. That's what the W character is there, a lowercase Greek omega. So we can think of a clique as a complete graph that just exists in some larger graph. The number of vertices in the largest such complete subgraph is called the clique number of the containing graph. In this definition, we say a largest clique instead of the largest clique because the largest clique is not necessarily unique in every graph. Let's see some examples. What is the clique number of this graph G1? At a glance, we can see this triangle. That is a complete subgraph on 3 vertices. And there is no complete subgraph with more vertices in G1. We have these 4 vertices forming a cycle, but they're not all joined to each other. So the clique number of G1 is 3. And again, that's because 3 is the order of the largest clique in G1. So what about G2? In this graph, the largest cliques we have all are of order 2. Just each edge with its end vertices is a clique of order 2. There's no bigger clique, and so the clique number of G2 is 2. That's the order of a largest clique. And as we can see, they're certainly not unique in this graph. There are 4 such cliques. G3 is a much messier graph. We can certainly see that the clique number has to be at least 3 because there are several triangles here. But upon closer inspection, we can find the clique number is actually 5. All 5 of these highlighted vertices are adjacent to each other, and the remaining 2 vertices are not adjacent to all of the other vertices. So indeed, 5 is the order of the largest clique in this graph. So 5 is the clique number of G3. Determining the clique number of a graph is certainly not always easy, but a few examples we can quickly knock out are that the clique number of the complete graph, Kn, is obviously n. The whole graph itself is a clique and is the largest clique that belongs to the graph. Similarly, the clique number of the complement of any complete graph Kn would be 1. Every vertex would be an example of a largest clique in such a graph because it would have no edges since it's the complement of a complete graph. And the clique number of any cycle graph, Cn, is 2. 2 other facts worth mentioning are that the vertex independence number of a graph is k if and only if the clique number of the complement of that graph is also k. This is because the maximum number of mutually non-adjacent vertices in a graph, that's its vertex independence number, is obviously the same as the maximum number of mutually adjacent vertices in its complement, which is the clique number. And also, the chromatic number of a graph G, the number of colors needed for a proper coloring of the graph, is at least as big as the clique number, because if the clique number is k, we've got k vertices that are all mutually adjacent, and thus we would need at least k colors to color those vertices before even moving on to the rest of the graph. So certainly the chromatic number of a graph is at least as big as its clique number. Let me know in the comments if you have any questions, and be sure to check out my graph theory course and graph theory exercises playlists in the description for more. Thanks for watching.
Persistent, couldn't even open myself up from